Welcome, truckers, to this flight for Lufthansa 361 from Dubai to Frankfurt. This is going to be a full flight in XP12. Thought it would be a good test of the new Dubai airport scenery. It's new in this new 12.3 through some terminal buildings, and here is our aircraft for the day. So this is the new Dubai airport. This is default scenery, something I think X-Plane does particularly well. The Tolis A330-900. Here you can see Dubai. Really good job on this. Looks very, very realistic. We've all seen those pictures with all the Emirates planes around these strangely shaped terminals. Reminds me a bit of Charles de Gaulle, but Dubai is better. CDG is not a port to go through. Here's our Lufty over here, sat by herself. I've made a start on getting a flight plan in place. Show you now. Do that. There we go. So we're going to be taking off from Dubai, flying up through Iraq, over Turkey. We're going to be going over land again around Bulgaria, flying over Romania, through Slovakia, into Austria. That would be quite a feat, wouldn't it? Austria, and then up into Germany. There's probably a Hungary in there as well, but my geography is not great. But this is going to be around about a 7-hour flight in our rather fantastic A339. So, just make sure we are connected to, which we are not, to X-Plane, to X-Pilot. And this is going to allow us to fly with some traffic, which you can see there in the distance. The Emirates push back. Over here, we've got a SAS, Swiss Air Service there. Traffic. The Emirates 777. Another Emirates 777 there. What have we on this side? I've got an 8. Beautiful. So yeah, it's nice just to get a little bit of traffic. It just makes it a bit more realistic. So what have I done in here? I have turned on the external power. I've switched everything on, so we have no lights. Lights on. Airbus operates a lights off policy or philosophy in their cockpits. Any lights that are on are usually not correct, or manually set up. So these have been manually switched on by me, but all these lights are off, which is good. It means everything it should. Let's the IRSs are now aligned. We've now got the navigation display showing up here. We've now got our PFD, primary flight display, also showing. They start very dark. Nice and bright. And I was just in the process of setting up the aircraft. So, just quickly bring up the flight plan. Going through some of the some of the numbers in here. So we've got 306 passengers that's been set up. We're taking no cargo at all. Total payload of 306 times 100 kilos for each passenger. At zero fuel weights 5. Takeoff well within the maximum takeoff weight of 224. Okay, so that's all good. Let's just double check that our zero fuel weight is 16. By those settings, 306, no cargo, a little bit more fuel than on the plan, just be paranoid about headwinds and things. Oh, weight and balance, WB. So we're going to start there, and then we're there, so we will be below max landing weight. Land. Weight summary, zero fuel weight is 165, which is what we said. Fuel 42, slightly more fuel than expected, so this 6. Take off performance, so we are going to take off from way 30 right. Pop these numbers in. Zero fuel weight. Block fuel is 3.2. That's very far. 42.2. I do it. 42.2 is our block fuel. So we're going to have about 1 hour 13 minutes of fuel after we've gone through. We haven't set an alternate, but that's. I don't think we'll need it today. The weather looks absolutely fine. Both in Dubai, where it's 38 degrees, and in Frankfurt, where it's 18 degrees. Fuel prediction. Knit is all. Flight plan. So we've got the flight plan all set up. This has all been set up within SimBrief, simbrief.com. A real life flight plan using the latest AirRack, the air data, the routing data. So this is genuinely as real as it gets. So we're flying real IFR flight plan. We're flying a real real route. Lufthansa 361 is the flight that does this route. So it doesn't get any more real than this. Let's look at our performance. So we've put our. Okay, so we need to put our own V1, V2 flight plan. Click on OMDB, go to departure, choose the departure runway of 301. Let's bring up the flight plan because this has got our desired. We want to go on the RIDAP 3 Golf. Departure, SID, RIDAP. For some reason we only have the 2. Maybe that has changed between the August AirRack, which is I've actually got installed. Be good enough for now. We've got the RIDAP 2 Foxtrot. Wasn't it? No, 3 Golf. Well, that's fine. That should be current. I think it was expecting a different run. We've got the Foxtrot departure, which we should now see on our navigation display. Out a bit. We're going to take off, we're going to go straight ahead. Go straight ahead up to EB585, and then we're going to turn left. easy departure. Turn left a little bit, go straight ahead. Really, really easy to get out of Dubai by the looks of it. Like I say, I don't fly out of Dubai very often. QNH 999 hectopascals is setting. Let's get our V1, V2, and VR speeds. So 30 right. I'm going to do a flex takeoff. Configuration. Give us. So V1 will be less than halfway down the runway, but at our weight, it's going to take a lot of time for us to slow down. So V1 is basically where it's the last point that it's safe to slam your brakes on and stop. Rate stop distance. That gives us a 402 meter margin. We'll be using a 1, top setting 1, flex 51 thrust, doing 132 V1. 132, 156. So let's go back to perf. 136 is going to be our V1 speed. 156 is going to be this 6. 6. 57 for the V2. So let's put 167 into our speed. I know that this is more of a Boeing thing, but I do like to have 16. A V2 plus 10 indicated on my PFD when I take off. Means that if we have an end out, then we can easily see visually what the best rate of climb with one be. Do we have rate? Might speed limit 250. Don't think we have an altitude constraint on the way out, so let's just set our altitude at our cruise altitude 360. Good. So, if you just bear with me for a moment, I'm going to pop you outside. I'm going to do a quick audio check. Be right. a quick modification to one of the filters on here because it's flipping when I talk. Click, 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 click. Okay, I think we're good. So, got quite a lot of traffic here. Should we tune into the let's tune into Unicom and then see what get out of the way. Armrest. And then we'll see what's going on. So this may be a bit loud. How do I do this so it doesn't blow your eardrums out? So flip that over. Nobody's transmitting at the moment. Okay, just turn that down a touch. Just until we know. I'm just going to arm the speed brake. And I think we're just about ready to go. So just make sure there's nothing around us. And then we'll call for a turg, and that will push us back. What's the best route? So if you press M and then zoom in, you can actually see a pretty good routing chart. So I wonder if we would actually go face northwest, go Lima 2. So yeah, let's completely avoid this runway. We will go Lima 2, Mike, and then we will hold at Mike 15 Alpha. Cool. And that guy who was talking there, I didn't hear him very well, so let's just turn up our radio just a little bit. So these volume controls down here do actually control the XPilot audio as well. Oh dear, we've got a guy who's about to speak, and he's quite loud, so apologies. We've got a better pushback down to start pushback.
Ground to cockpit, please show me where you want to go.
There we go. So we want to be pushed back to here. And I always end up going on that part when I shouldn't. This is actually the taxiway here. That will do nicely there. So if I press enter.
Ground to cockpit, tow is driving up.
Tow is driving up. Marvelous. Just curious why that was coming out of those speakers when in reality it should have been coming out of my headphones. That's better. Hopefully you can still hear that. So we should now have, if I don't type into there, you can now see the tug is at the front of the aircraft. That will then drive up.
Okay, all doors and hatches are closed, ready to connect.
Go right ahead. So it's going to drive, it's going to capture the front wheel, and it's actually going to lift the front of the aircraft up, which I'm going to try and show you here. So, right, I've stopped moving there, so this thing is going to drive under that nose wheel, and it's going to lift the aircraft up. So if I put my mouse just on the middle of the radome.
Dubai traffic, runway 30 left, vacated.
Runway's vacated. You can see the nose is going up, and you will feel this as a passenger. You do feel the nose raise up. So that's just
So connected and bypass pin inserted. Release parking brake.
So we're not going to release the parking brake yet because we haven't radioed to let people know that we're going to push back. So let's do that now. Which gate were we at again? Charlie 57. Dubai traffic, Lufthansa 361, Charlie 57, pushing back, facing northwest, Dubai. Not my worst radio call. So now if we jump back into the cockpit, turn off the parking brake. Bosh. Is the...
Starting pushback, and you may start engines.
And you may start engines. Oh, they've changed the buttons around. So in order to start the engines on the Airbus, you have to go down to here to the engine start panel. It's currently a norm, but you go to ignition start.
Dubai traffic, Spielberg 9 Foxtrot Heavy. Taxi
Turn on engine
to
1.
gate Foxtrot.
Why have I lost my...
20. Straight ahead. Dubai traffic.
Why? Oh. I didn't start the APU, and I just pushed, and now we don't have external power. That's why. So let's just quickly get the APU fired up as fast as we can. That was a very, very silly thing to do. I probably also have, if we're going to ISCS, ground services, still have my high pressure air switched on. So none of this is going to work. We're on battery. Should see an error here. Low bleed air. Ugh. That was an error. So let's start the APU. So we start the master switch first. And then we hit start on there. That is pretty gorgeous though. Even though currently it has no power. So we need to turn the beacon light on. Come on, there we go. We'll finish fueling. Seatbelt sign should be on too. It's all going very well. Where is my APU? Okay, lights coming back on, which means that the APU should be available. So we've got APU power available. Let's get that switched on. So start bleeding from the APU some air, and that's then going to allow us, if I go back into, if I switch that off, it'll go into auto mode. EGT is increasing, and now we have engine start. So that's there, that's on. We haven't lost our IRSs, which is a good thing. We are going to get a few warning messages now. No fuel weight data. Oh, I'm sure I put all that in. Oh, I've lost it all. We have lost it all. So, we've got the APU on. I'm probably going to have to shut down the engines because once... Ugh. We do have IRS. We've got the air data inertial reference system is switched on. Company route was DXB Frankfurt 01. Oh, it's still not detecting all my clicks. DXB FRA. Set parking brake 01. There we go, insert that. Pax number 306. Bosch CI 33. IRS data is all aligned. Flight plan, we're going to take off from 30 right on the Redat to Foxtrot. Insert. In
Operation complete. Set parking brake.
Set parking brake. There we go, parking brake is set.
Disconnecting tow. Stand by.
Thank you, sir. What I am concerned about is... Okay, so we were 136. Why is it not recognising those clicks? 1, 3. 1. Come on. 1, 3, 6. Blocking a taxiway here. 1, 1, 5, 6. Disconnecting, give hand signals. V2 was 1, 5, 7. Flaps 1. Flex 2 temperature was 56. 56. Format error, marvellous. Oh yeah, so this is a bug, which means you can only really do toga takeoffs, but that's
Tow is disconnected and bypass pin has been removed. Hand signal will be on the left. We'll see you next time.
On the
Have
left.
a safe flight.
Okay, we'll keep an eye out for those. But I don't feel like I've set up those the weight. So where's the weight? And 0 fuel weight 160. Fuel on board. So is that error now gone? Still thinks we haven't got we haven't set our weights up, even though we have.
Dubai traffic Scandinavia 984 from stand Charlie
There
Pipeline,
he is.
pushing back facing east.
The Scandinavian's that one there, isn't it? Is it the Swiss Air Service or Scandinavian Air Service? I can never remember. I don't know why I'm getting that error. Saying no weight CG data. But we do. It's all in. I'm going to try shutting down the engines. Probably a period of time that I should start them before I start them back up again, but let's do number 2. Why is this not detecting my clicks very well? So this is the beta of 12.3, so maybe this is just one of the things that's currently in progress. So N2 is spinning. Fuel flow. Wait for the fuel flow to come on. Fuel flow is now on. Should start to see an increase in N1. EGT is increasing. N1 should start spinning. There's the N1. SAS is pushing as well. 767. Nice. But we are still slightly blocking the taxiway. You see the heat haze from the APU at the back. It's quite nice. So left engine is on. Let's turn on the right. Right engine is on. Let's turn on the left. Still seeing we don't have CG data. I'm just going to ignore that. I think that might just be a bug, or because I pushed back while the power cart was still attached. Hopefully they're not going to block my access to that taxiway. So we've only got fuel in the wings, and that's standard. So EGT is increasing. Where's the N1? So it's a 3-spool, which means it's a Rolls-Royce. Rolls-Royce is famous for their 3-spool engines. So N3, N1, and N2 will be there. N2 on the lower ICAS. Is it ICAS in the Airbus? Engine instrument crew alert system. So I think we have to... Where the hell are they taxied onto? Okay, let's announce our intentions and get in front of that Scandinavian. Dubai traffic, Lufthansa 361, taxiing to holding point for runway 30 right via Lima 2 and Mike. Dubai. Goodbye, Dubai. Okay, so I'm just going to ignore that. Brakes are off. Little bit of power just to get it moving. Need to overcome the, what do you call it? Static friction. And then it's easier just to maintain rolling. Is the parking brake still on? It's not going to help, is it? So a little bit of power should get us moving. There we go. Get in front of the Scandi. Far too much power. Still need no more than 30 N1 to get around. So we're going to turn right here. Onto Lima 2. Turn right again onto Mike. Mike's quite a long taxiway down to the beginning of down to the holding point for runway 30 right. So there's the taxiway. You need to drive past the line and then start turning, because the nose wheel is behind the cockpit. Probably a bit too far, but we'll see. We'll see. We'll see. Just a little bit too far. So this is a hill. This is actually requiring a bit more power to get up the hill, which is quite nice. One of the things that really attracted me to X-Plane back in the X-Plane 8 days, maybe X-Plane 9, was the fact that the airports weren't just completely flat. The runways had lumps and bumps and things like that, and I thought that was pretty cool. So we're going to taxi up here and then turn right onto Mike. We're currently on Lima 2, turn right onto Mike. And then, in fact, if we look to the right, that's the runway. That's 30 left. That's what people are landing on right now. Not doing a good job of staying in the taxiway. Very, very slow to react. The steering on this. I guess I just need to preempt the turns a bit better. And this looks pretty downhill from here. See the nose drop. So I'll probably back up on the power a bit. Definitely feels like we're going downhill there. Power's all the way back to idle. At the bottom here you can see our ground speed is displayed at 22 knots, so we're actually speeding up even though we're at idle power. May need some brakes, but I'm happy to get to the holding point sooner than later because this is going to be quite a long flight. Speedbird over there. And we're looking for, was that Alpha 15 or Mike 15? Let's quickly bring up the map. So we're there, and we're going to go down here. It's going to be Mike 15 Alpha down here. to cut this off. So now that we're on more flat ground, you should probably see that ground speed reducing a bit, which we are. Let's just introduce just a little bit of power, keep that speed up. There's 5 alpha, we're looking for 1.5 alpha. That's one of the high speed turnoffs, so if you land, you can keep quite a bit of speed up and go off one of those high speed turnoffs. That was to the left. Need a bit more power to keep that speed up. Still on mic, very handy M painted on the taxiway there. Look at all those clouds in the sky. Completely alien to us Brits. One of the fun parts about learning to fly is the meteorology training that you have to do, and finally you get a name for all of the clouds that you see in the sky. As a Brit, you get to complain about the weather in a completely new dimension. It's fantastic. Okay, what's this one coming up here? That's 9. So we probably should have our taxi light on. Runway turn off lights on. Seatbelt signs are on. I can stay in auto. So mic 12 is that way. I'm still waiting for mic 15. Mic 15 alpha. So this is going to be a longer run than just mic 15. I'm going to use a lot of this runway, even though we don't need it, because we're going to do a toga takeoff, and these are very long runways. They're designed for the A380. Just basically one of these with another one sat on top. Let's just see. That Dubai airport is pretty nice. It's been modelled really well. That's mic 14, mic 15, and then it's going to be ours. So I am going to just gently apply some foot brakes. So next one is mic 15, and then it's mic 15 alpha. In fact, you know what? Let's just do 15. Let's live dangerously. Runway ahead. Nobody is on the approach. Nose wheel did something a bit funny there. Dubai traffic. Lufthansa 361 ready for departure, lining up runway 30 right, Dubai. And this joystick's got a heck of a creak to it, so I'm going to turn off the microphone during the takeoff, so you don't have to put up with that, and then I'll turn it on once the autopilot's switched on. Get nicely lined up. And then let's get back to Germany. Süddeutschland. Not a fan of how slow that nose wheel turns. Okay. Microphone off. Let's get this baby in the air. One quick thing. Dubai traffic. Lufthansa 361 rolling runway 301 at 30 right. Dubai 301. Jeez. Right, let's go. I need some flaps. Did I put my flaps down? Nope. So there's a takeoff button, takeoff config button there. For some reason isn't working. Predictive wind shear is off. Predictive wind shear is there. Switch up to auto. Do takeoff config. All green. Okay, let's get this baby in the air because people will start waiting for us. There's the Scandi. Manual toga. Knots, switching to rudder. Said I was going to turn off the gosh, you need a lot of, yeah, let's turn off the microphone here because I'll need the joystick in a moment.
Dubai traffic, Emirates 3 Yankee landing up runway 3, Dubai traffic.
Okay. Autopilot is on, still in manual toga. Bing. Transponders in standby. Also, we don't need that there. How do I turn on? TARA, that's all, that's in auto. So we should now have cleared that message. Still complaining about the weight, but I'm just going to choose to ignore that. So in here, leave it into the climb mode. This has got a quick view of Dubai with satellite injected imagery. We saw the Burj Khalifa just on takeoff, during takeoff. There she is. And now we can roll this back into the climb detent. So you'll start to see the nose lower. Flaps are up. Nose is lowering for acceleration. Climbing through 3,000 feet. This is going to start blinking at us when we get to the transition altitude. Which actually I don't know what it is in Dubai. That doesn't look too realistic, does it? Okay, we're off. Let's go to Frankfurt. So still on the APU. Let's just make sure that we can get that switched off. If we put the electric panel on, we've got the generator. So the
Dubai traffic Scandinavia 984 lining up 30 left. Dubai traffic.
30 left, you crazy man. So we'll turn off the APU. APU bleed is off. Just monitor to make sure that we haven't got any faults. So the left engine is currently providing AC power. If we go to electric DC, the APU will wind down in a moment. Yeah, I think the left engine is providing all the power. Why is that? Why is that? What have I not switched on? So turn off the APU bleed.
Dubai traffic, Emirates 3 Yankee, airborne of runway 30 right, number 3 Foxtrot, Dubai traffic.
No idea. I'm going to trust the aircraft. It knows what it's doing. Oh no, because that's generator 2 going into there. Okay, still not getting complained at about using a QNH, but if we just pull that, that'll go to standard mode. So now in the standard pressure setting, let's zoom out so we can see where we're going. We'll go up to the right, and that's our top of climb, 120 miles away. See if I can jump outside without deafening you. Yeah. There's a boat down there. Looks like an aircraft carrier. Getting a nice 53 frames a second. Just want to say hello to our watchers from Yorkshire and from India. Friends of mine I just had a message from. Appreciate you watching. Okay, maybe we should go through some of the systems on the aircraft. Let's start with the screens down here. So the lower ECAM shows you all the information about the aircraft. So you've got your engines up here, but then you've got a lot more information that gets shown on the lower screen. So you can cycle through them by going to the All button here, and it'll just cycle through each one. But what we can do is let's start with engines. I mentioned that this is a Rolls-Royce powered A330. So you can see here the you've got the 3 spools. You've got the N1, which is the low pressure turbine. You've got the N2, which is the intermediate pressure turbine. Then you've got the N3, which is the high pressure turbine. Further back in the aircraft, in the engine. Let's see, what's our fuel flow at the moment? So we're currently using about 5 metric tons of fuel in each engine per hour. 10 tons of fuel. Now this is just during the climb. Use a load of fuel during the climb. But we've only brought 40 tons with us, and this is a 7-hour flight. So if you maintain 7 hours at 10 tons, you obviously need 70 tons. But once you're up at the cruise altitudes, this fuel flow reduces considerably. And then for the last half an hour of the flight, you're just pretty much at idle as you come through the descent. So fuel on board's 40, and we are going to see that number drop considerably as we climb. But that's the engines, so you can check the oil. One thing that is new in this beta version of XP12 is you can set aircraft age, and that lets you, that shows different aging characteristics, different vibration qualities, different fuel use, different temperatures for the engines as well. So you can set the age of the engines. Okay, so let's go through the next screen. So this is the bleed air system. So this is the air coming in from each of the intermediate pressure turbines of the engine. And you can see it's currently being pumped in at 44 psi. The temperature coming out of the engine, the air coming out of the engine is 199 degrees Celsius. So that then goes through and gets mixed with cold air, thankfully, so it doesn't just boil the people in the cabin. And it goes from 190 Celsius to 7 degrees fairly quickly, and then you can just pull in different amounts of hot and cold into the cabin. You can increase the pressure, so there's the high pressure turbine there, and I think if you go to I know exactly where this is on the Boeing, but not here. Maybe not. If I turn on, nope. No, I don't know. There's a high pressure mode anyway in the 737 that you can turn on. So let's go to cabin pressurization. So the outflow valves, you can see forward and aft, are closed. As we get closer to the ground, they will start to open to release some of the pressure in the cabin. Current delta pressure is 5.3 psi, so there's 5.3 pounds per square inch on the doors and on the inside of the cabin, but not on the outside, which is quite a lot. So when we get up to altitude, and it's going to be around about 8 or 9 psi, there'll be more than a ton's worth of air pressure holding the door shut. So if you see somebody stand up trying to open a door in flight, don't worry, it's not possible. So while the aircraft is climbing at 2,000 feet per minute, the cabin altitude is only climbing at 330 feet per minute. So the cabin altitude is currently just over 4,000 feet, quite comfortable, nice and breathable, and basically the cabin pressurization system will stop that from going above 10,000 feet cabin altitude. That's when you start to get hypoxic. What else is in here? So we've got 2 packs switched on, and that's the passenger air conditioning kits. Current gross weight of the aircraft is 204 metric tons, pretty heavy. Total air temperature outside is 11 degrees Celsius. Saturated air temperature is -9, and we're basing this on the international standard atmosphere of 15 degrees. Okay. That can't be that. No. Let's go to the next screen. AC power, like I say, currently seems to be going into the what do you call this? Something regulator. It's the power regulator anyway, for power coming into the AC system, and then it goes into the essential bus. Currently being fed from the integrated drive generator 1, and then we've got generator 2 on engine 2, and that's currently doing the TR2 system and also the APU's power regulation system as well. So that's coming in that way. APU switched off. DC, so you've got AC1 and AC2. So AC1 coming from engine 1, going into the DC1 bus. AC1 is also powering the DC essential bus, TR2 and APU. So that's obviously not coming through from the engine, that's going into the DC APU bus. So it looks like engine 1 is actually doing quite a lot. Hydraulic systems, 3 hydraulic systems on the A330s. That's one of the differences between the A330s and the A320s, even though they have the standard Airbus cockpit configuration. When you do multi-fleet flying between the A330 and the A320 and the A330, one thing you have to be aware of is there's an extra hydraulic system in the A330. The reason for that is ETOPS, extended twin operations. So this is when you can fly over water for long periods of time without a near diversion airport. So the extra hydraulic system just gives you that additional redundancy on the A330. And this is the A330-900. It's the very latest Airbus sorry, I hear some crackling on the radio. So this is the very, very latest NEO new engine option Airbus. So this all looks good. We've got good hydraulic pressure. You can see there's also electric driven hydraulic pumps. So you could basically lose the hydraulic pumps in here and then switch over to the electric driven. If all those fails, you've also got the ram air turbine, the RAT, that you can also plug into the green system, which will give you basic controls, the fundamental controls. Circuit breakers, all normal. APU is currently switched off, so bleed air is at 0, no APU generator. We used 170 kilos of fuel in the APU on the ground, and all the temperatures are coming back as 0. Temperature, so you can see the temperature, hot air coming in, cooling through the cooling systems, and then these are the different zones in the cabin. Yep. All the doors are closed, thankfully. You can see the individual tyre temperatures. So, or rather, you can see the individual brake temperatures. So you can see the PSI, you can see the pressure in each tyre, and you can also see the temperature of the brakes. So these are still at 70 degrees and 80 degrees because of the braking that we did on the ground. When we come into land, or you can also see the position of the doors, the landing gear doors. When we come into land and we apply brakes on the runway, I'll try and leave this page up, and you'll see the brake temperature increase considerably. We do have a brake fan system, that's up here, brake fan. If things get too hot, you can cool them with some very, very large brakes or fans that are attached to the brakes. Flight controls, not a lot going on at the moment, thankfully. In nice stable flight, you may be able to see occasionally some of the elevators twitching, maybe just a little bit of movement from the rudder, just trying to keep things stable, but we're not really in turbulent air right now, so the autopilot doesn't have a lot to do. So you may see prim in sec and think that's primary and secondary. That's not. Prim is the primary flight controls. Sec is the slat and elevator controls, and they're controlled by different hydraulic systems. So you can see all around here you've got the yellow, green, blue. So let's take let's see. So elevators. So the left elevator system is controlled by blue and green, and the right elevator system is controlled by green and yellow. So let's say we lost the green system. You'd still have the yellow controlling the right elevator, and you still have the blue controlling the left elevator. So you can lose an entire system and still have full use of all of your flight controls. But if you lost two hydraulic systems, so let's say we lost blue and green, the rudder has actually got 3 different systems going into it, so you'd still have full use of the rudder, but you would lose your left elevator. So you'd only have the yellow system controlling the right elevator, so you'd see sluggish pitch control. And then the same for the ailerons, so yellow system and green and blue systems there, but it just means you've got massive amounts of redundancy. Entire systems can fail, which is very unlikely, but does happen in very, very rare circumstances, and in this scenario the aircraft would be fine. Let's look at the fuel. I mentioned that all the fuel is in the wings. This is standard. So what you normally do is you fill the wings up first before you fill up the centre tank, and that's because the weight of the fuel itself is used to weigh down the wings to counteract the lift moment from the air flowing over it. So that it just kind of weighs them down and just reduces the bending in the wings. It's just to reduce some of the structural impact on the lift. So we're currently using 140 kilos of fuel per minute because we're still in the climb, but that'll be stopping shortly. Oh, still got the seatbelt sign on. Let's release those passengers. Turn off the no portable electric device sign. What else have we got? Status is all normal. Back to the engines. If we now jump into the FMCU, Flight Management Control Unit, then we can go to progress page. How do we see in here? Let's see. Thought it'd be in there. Nope. We'll see it in here. So we're going to arrive in Frankfurt at 16:13 UTC, which is 2,500 miles away, and we're going to land with 9.5 tons of fuel on board. Okay, I am going to hop outside. Left my wing lights on, and I'm going to have a quick break. Back shortly. Okay, let's jump back inside. Just see where we are. So we're at the top of the climb. We were using 5.2 tons per side of fuel during the climb. Now we're using 3.5 tons per side. Quite a significant drop. Let's just see what the most economical altitude is going to be. So in the cruise, how do I find min and max again? Oh, there we go. So the optimal is slightly lower than we are at the moment, and the max is just shy of 40. So we're going to stay at 360 until the optimal gets closer to 380 than it does 36. So when it gets to 371, for example, 37,100 feet on the standard pressure setting, then we will move, then we will climb to flight level 380. We'll call that a step climb. Let's have a look. So, whoop, that changing buttons is going to confuse me. Let's have a look at the PFD. So across the top you've got what's known as the FMAs, the flight mode enunciators. It's currently in Mach mode, so we're maintaining Mach 0.81. If I just go to performance, it's trying to manage us and just maintain 0.81. So you get a third decimal figure just to see where we are in the range, but it's going to maintain 0.81. Standard is, it's got the yellow box around it. Why does it have the yellow box around it? No idea. Okay, so currently it's in Mach mode, it's maintaining the Mach. It's got altitude cruise mode, so we're in the cruise, 36,000 feet. And navigation mode is effectively controlling the lateral navigation. So the lateral nav is turning left and right across the Earth. That's the lateral mode. Vertical mode is maintaining an altitude. So it's in cruise mode and it's maintaining this altitude. That's controlling the power. And then you've got the speed mode, which is currently in Mach, and that may be in speed mode SPD when you're closer to the ground. So you can't even change it when you're in the cruise. The navigation display, and also at the top right of the PFD you'll see we're currently using autopilot 1, so it's using the left hand side autopilot. Auto throttle is also engaged. Auto throttle is engaged, and both the captain and the first officer have got their flight directors on. So if I turn off my flight director, you can see it's highlighted here that only one of the flight directors is activated. Turn that back on. Let's go through the navigation display and then we'll talk about some of the modes that we have up here. So this is currently in arc mode, so you can see ahead of us. So you get how many degrees is that? That's effectively, that's 90, 100 and a bit more. So you effectively get 100 degrees of arc ahead of you. You can see our path through there. You can see some of the, what is KFR? Is that an airport? Because I don't have airports switched on. I can switch on airports there. And switch on VORs. VHF omnidirectional range beacons. Got waypoints, so these are all the waypoints that you can navigate through. And then we've got constraints. So we don't have any constraints on our route at the moment. We do, by the looks of things, have an aircraft slightly behind us and 2,000 feet below. So let's just hop outside. Over there, Qatar 2 Whiskies just behind us. These Airbuses are phenomenal. Tolus does a phenomenal job at building them. So yeah, we've also got traffic showing up on here. They're 2,000 feet behind us. What else is on here? So we have our next waypoint, Ralka, on a heading of 322. So we're just going to head out along 322 to get there. It's 43 miles. We'll get there at 11:12 UTC. So the time's currently down here, 11:07. We'll get there in about 5 minutes after travelling 42 nautical miles. So we're travelling 1 mile every 7 seconds. So let's just tick down. 1, 2, 3, 4, 5, 6, 7. So every 7 seconds we're travelling 1 nautical mile. Top left, our ground speed is 472 knots, but our airspeed is higher. So our speed through the air is actually 477 knots because we've got a wind from the front. We've got a headwind. So the wind is currently coming from 392, so it's coming from this direction. And its strength is only 7 knots, not very strong wind at all, given the altitude we're at. You normally find stronger winds up here. But it is slowing us down by 6. The actual impact on our direction this way, the vector, is 6. That's the difference. So this is the wind. You'll also notice you've got a yellow pointer here, which is the track that we're on. That's the direction that we're heading across the Earth's surface. And then you've got a green diamond, which is where the nose is pointing. No, other way around. The yellow one is where the nose is pointing, because that's going to be slightly to the left of our heading, because we've got a slightly left headwind. And then the green is actually our track across the ground, across the Earth, because these waypoints are on the ground, effectively. So we are tracking across the ground from one place to another, but our nose sometimes doesn't necessarily follow the track because of the wind not being directly in front or behind, and maybe trying to blow side to side. So you'll notice that the aircraft is currently tuned in, auto-tuned, 2 VORs. So one is tuned into KUA, ahead of us to the front left here. That one is 35 miles away. And then you've got KFR over here, which actually looks closer than KUA. No, it's not, because you've got that range circle there. So KUA is 34 nautical miles away. KFR is 43 nautical miles away. Something's happening with the traffic behind us. So what will happen is, as we go from... just turn on the VORs. As we go from place to place, the aircraft will tune in VORs to help support its understanding of where it is in the world. So as we get past KFR, we'll probably see KFR change to whatever this one says. Can't quite read that. Looks like there's 2 of them very close together. AUR? PUR? ASR? ASB? Something like that. But I expect KFR will shortly change to that. And then it'll auto-tune ABD, and then I guess that's Basra in Iraq, which means that we're probably going to be over the ground shortly. And we'll follow, I think that's the Tiber in Iraq. So this is all still injected satellite scenery through auto-ortho, so it looks pretty good. And then if I just sit up in my chair a little bit, you can see some of the nice effects of the delta that we have here in the Tiber. And then we'll fly over Iraq, which is this country here. Okay, so let's see. So we're still both tuned on KFR and KUA. We're getting further away from KFR. I think the closer we get to this one, it'll tune it in, because the closer you are, the more accurate the VOR signals are. Do we have any NDBs in the region? A couple. So these are non-directional beacons. That you can actually use to navigate and fly to, but there we go. I quite like an NDB approach, quite challenging even in a Cessna. That's the primary flight display and the navigation display. I did talk before about using magenta for, what was it? I think it was when we had the external power switched on. So magenta and cyan are used very specifically in the Airbus cockpit. Cyan is something that's requested by the pilots, which is effectively an override of the normal state. So you can see here we've currently got we're in a managed speed mode. It's managed with Mac, but if I pull out the speed control, I can override this and I can request 8.2, and you can see we now have a little cyan a triangle on here, which is an override mode, which the aircraft is now going to try and capture. What's missing on here, and I'm not sure if this is just because it hasn't been developed yet, is normally you see a magenta number on the top of here, which is the actual, but I think it's just been replaced with these green numbers underneath. Not sure why that is. Maybe it's just the new philosophy of the Neos, but yeah, it does make sense. So if I now push this forward, it goes back into managed speed mode. See managed 8.1 down here. So the throttles have just gone back a little bit, down to 76% N1, while we slow down. And as we capture the magenta, so there's the magenta, that's the managed mode. And now the engines will spool up just a little bit just to maintain that .81 speed. So still on KUA, still on KFR. I think we'll start tuning 8. Oh, there we go. 117.95 on the VOR2. And I think that's going to be ABD. Hasn't got the, so each of these signals actually, each of these beacons send out a Morse code, and that's the Morse code of their VOR code of their name, basically. So once the aircraft has received that Morse code and has decoded it, then it should be able to display the VOR name. So 117. It's going to be in the NavRad page. Here we go. So we've got RadNav down here. We've got KUA 114.15, and the frequency has been set of 117.95, but we don't have a VOR code for that. Maybe it just doesn't broadcast Morse code. And these are very likely to be quite realistic. So if the VOR station doesn't broadcast a code, then somehow X-Plane has got all this in its database, and it understands where you'll just see the frequency and where you'll just see the where you'll actually see the code. I'm not quite sure what the M underscore means, to be honest with you. Not sure. What you can also do up here is you can actually switch off the VOR display. If I go to off, then you can see it just disappears. We can also just set it to ADF mode, automatic direction finder mode, but right now we'll just leave it as VORs, just so we can see what the plane is doing. Now, I mentioned, sorry, it's because that's an NDB. What it's done is it's tracking an NDB. And I know that that's the case because NDBs don't... actually, is that the case? I'm not sure. The reason why I'm saying that is because I can see the ADF is actually lined up more or less with that beacon there. So yeah, what you'll often find as well is if you've got a VOR tuned and it's an ILS, you can also set your course, and it will you'll be able to see the course showing up on here, the runway direction basically showing up on the navigation display. So I think we're over Iraq now. A lot of high quality satellite imagery over Iraq. See all the roads. Anything down there? And the plane is just banking to the left. Oh, you can see Qatar 2 Whiskey is just overtaking us below. Those cheeky Qatarians. Can't see them quite yet. They must not be in a managed mode. Must be in their cyan override mode. That's pretty cool. And it's in the Qatar livery. There it is. Qatar 2 Whiskey. Cheeky. And we should be able to see them on the navigation display. Oh, hang on. I thought I saw them climbing there for a second. Because if they're 2,000 feet below us, check, and they start climbing, they're just going to climb straight into our path, which is going to be a bit dangerous. So, oh, my ground spoilers are still armed. And if they were to start climbing into our path, I would first of all communicate on Unicom, say, oi, stop it. But then I would also apply SLOP, not AI SLOP, but strategic lateral offset. Procedure? I think, yeah, strategic lateral offset procedure. So I would fly, I don't know if you can actually do this in the FMCD, in the FCDU, but this is often done in Africa, where you've got aircraft not necessarily adhering to the evens and odds flight levels, because a lot of Africa is just uncontrolled, but where aircraft are using the same waypoint, they would apply SLOP and they would fly 2 miles left or right of the waypoint, just to give themselves a bit of leeway. But if can I do that? Just wondering, is there somewhere I can do flight plan? Is there an option to apply SLOP? Direct, nope. Progress, nope. I can get the bearing and distance to a waypoint, so if I put in my arrival at EDDF, which is 311 on the heading and 2108.0 nautical miles away, that's pretty good. If I wanted to divert to Oh, let's see. Turkey? No, if I want to go to Sofia, because I can actually remember that code. So L is kind of Eastern Europe, B is Bulgaria, S, F is Sofia. That's 1,300 miles away. Let's see, is there anything closer? Trying to remember what Istanbul is, but I can't. Nope, completely slipped from my head. But anyway, Sofia is probably one airport we can land at as a diversion if we need it. Let's see, Qatar 2 Whiskey is really motoring now. Seems to be considerably faster than us. Now, if you go on a browser and go to map.vatsim.com, it'll take you to vatsim-radar.com, and you can even see how can I bring this up? Let's see. Yep, so this is us. We're flying Lufthansa. Don't know why that's selected. This is our aircraft here. It's currently squawking 2000, which probably shouldn't be, but ground speed is 265. I was going to have a look to see what the ground speed was. So their ground speed is 500 knots. They are flying 40 knots faster than us, which seems unrealistic, given the fact that we're already doing Mach 0.81. But you can track. Let's see. So over Kuwait into Iraq. Got some traffic heading down. Got another Qatar heading towards us, Airbus A350. Just as the aircraft is making a bit of a right turn. So let's turn this off and you can watch that. And we should shortly be seeing another Qatar coming towards us on the right hand side. Yeah, cruising over Iraq. There is the other Qatar just shown up there. So they are 3,000 feet above. And we could probably start seeing them pretty soon. There they are. There they are. Qatar 706. So optimal flight level is still at oh, okay. That's jumped up quite considerably, hasn't it? So the optimal is now at 370, so we should be starting to do a step climb. So we do that just by changing that to 380, and because we originally put 360 as our cruise altitude in, we're going to push it. What you'll see is fuel flow will increase first. Fuel flow is increasing to 4 tons either side. So the N1 has increased, N3 has increased, and as a result we have some vertical speed on the VSI, vertical speed indicator. And we're just climbing through 36,300 feet on the standard pressure setting, also known as flight level 364, flight level 365. So we've got plenty of performance. We're still climbing at more than 1,000 feet per minute at this altitude. It's not like we're at 100% N1. So our climb limit is 93.5%, which is what we're currently at. That's the speed, that's the thrust limit. You'll notice that our wind is increased a little bit, so it's gone to a 19 knot wind, and you can see our track along the ground is there, but because we've got a stronger wind from the left, our actual nose of the aircraft is having to tilt more to the left hand side to compensate. Should see that Qatar over there. Zooming past. Very high mountains off to the right hand side there. What's going on down here? Looks like some sort of agricultural project. Looks quite wet. Guessing there's quite a lot of irrigation and stuff going on down there. A bit hazy up ahead. So we're now at 38,000 feet, flight level 380. And our fuel flow has decreased to 2.7 tons each side. That Qatar is descending, is it? See if that... So it's currently 4.3 thousand feet, so 4,300 feet below us. And it looks like it's indicating that it's descending. So the left-hand side VOR, the VOR1, is now tuned into Basra. Just go to VOR. Where's Basra? No idea. Must be behind us. I'm guessing if the distance increases of 57, yep, so we're leaving it behind us. Are there any NDBs to tune into? Nope. VORs. The VORs, so it looks like the right hand side VORs lost its signal, so it's no longer giving us distance measuring. It'd be cool to do a VFR flight someday over Iraq. I do know some long-haul pilots who do flight instruction on the weekend, and they really look forward to the flight instruction because it's real flying, whereas this is just, you just follow the green line. But I think this pays better than flight instruction. So our cruise altitude is now updated because we've gone beyond our original cruise altitude, and that'll just correct the pressure so that we don't we try and maintain a comfortable cabin altitude. So the cabin altitude is 7,000 feet. It's pretty high, to be honest, by modern standards. If you fly in a Dreamliner or an A350, that'll be 6,000 cabin altitude. Both the outflow valves are closed, vent extractors closed, and the safety valve is also closed. Cabin altitude is not climbing, which is good because we're not climbing. And you have 8.4 pounds per square inch of pressure on the inside of the cabin walls, so quite a lot of pressure. But yeah, that'll be holding the doors firmly closed. You're not going to be able to open the doors in flight, don't worry about that. Apart from in Boeings, apparently, where they just open themselves. So that Qatar has vanished. We can increase our speed. We can increase our speed if I go to performance. Nope, I've done it again. Progress. So we're at the most optimal altitude, and in flight plan we're still estimating to arrive in Frankfurt with 9 metric tons of fuel on. That's quite a lot of fuel. So we can speed up. We can either override it ourselves by overriding the speed here like we did before, but instead let's change the performance mode, and we will change the managed speed to decimal 83, or we could change the cost index, but let's change the speed. Ooh, not allowed. What? Let's try changing the cost index. So that goes up to 129, I think, something like that. There we go. So we've increased the cost index. Managed speed is now decimal 83. So the managed diamond, the magenta diamond, is now changed. It's now increased. So we are increasing our speed, increasing our fuel flow, and that'll then change our estimated fuel at arrival. So we're going to use half a ton extra fuel, less than half a ton of extra fuel by flying at decimal 83 instead of decimal 81. But our ground speed is still 469, so I think that Qatar is cheating. I think they've turned off headwinds or something. Okay, so if we just turn this off, if I turn off one of the selections for the lower ECAM, is it ECAM or ICAS? I can never remember. I think it's ECAM, lower ECAM. If I turn this off, then the aircraft will choose which is the best mode to go into, which is cruise mode. So it's in cruise mode, and it's given us a synopsis of lots of different modes. It's given us engine information, temperature mode, cabin vertical speed, delta P for the pressure, cabin altitude, fuel used across both sides. So we've used 10 tons of fuel already. So this is now chosen to put us into the cruise mode, which is pretty cool. Let's see if there's something we can do to break it. So if I were to, let's see, what can we do? Something that's reversible. If I was to turn off the bleed for engine 2. Okay, I'm not going to do anything for a second. I thought I would have brought up the pressure controls, to be honest. If I turn off pack 2, there we go. We've got a bong. Air pack 2 is off, and this has immediately taken us to the bleed screen. So nothing is selected. The aircraft has chosen to activate the bleed screen, and it says that we've now got a reduction in, we're now no longer pumping air into the cabin from the second engine. So if I go to pressure, it says that pack 2 is off. Delta P is stable. We haven't got a change in our cabin altitude, so just if one pack did go off, the pack from the other engine looks like it's maintaining that pressure just fine. If I was to turn off the other pack, can I do that? You can now start to see the cabin is immediately climbing. That's dangerous because we're now seeing an increase in cabin pressure, or a reduction in cabin pressure, an increase in cabin altitude, and the cabin pressure is increasing very fast. The outflow valves have completely locked shut, but these aircraft do have holes in them, so to maintain pressure you do need to have these packs switched on. So that's coming up to 8,000 feet. If we get it to 10,000 feet, you'll start to see the cabin altitude warning come on, and I'm not sure if it's enabled. Ah, so the oxygen mask has come on. I don't know if that's automatic, but yeah. So what you should start to see is a warning shortly as we get to high cabin altitude. Now we have lots of things flashing at us. And as soon as the cabin altitude gets to 10,000, we'll probably start to see a master warning. Then I'm not sure. There we go. Master warn, cabin altitude. So it's now saying crew oxygen masks. Use your crew oxygen masks. So I've now got my oxygen mask on. Cabin altitude is getting dangerously high. Cabin differential pressure is reducing. It's an emergency descent. We're not going to do that. We're just going to switch our packs back on. And then I'm going to put the pack flow to high. And the reason I put the oxygen mask on is because I think you actually lose. Let's just take it off. I think the screen starts to go black as if you're going hypoxic. So now we have a reducing cabin altitude vertical speed. We're now reducing under 10,000 feet. Delta P will be increasing. For some reason they've slightly opened the valves. I'm guessing it's because we're in a high flow state and it could cause structural issues. I don't know. I think until the delta P gets back to 8, I would have personally left those closed. In fact, I can override that. Close. No, I can't. What's that for? Is that for the cross feed? It's for the cross feed. I don't know. Have I got control over those? Nope. That's quite annoying. Silence the master warning. It's basically saying do an emergency descent. Use full speed brake. Keep your speed at maximum just to help you get down as fast as possible. So cabin altitude is going to come down. But that was just a test to show that the aircraft decided to choose the cabin pressure screen. Still flashing on this synopsis page here. Still showing the cabin vertical speed descending and the delta P is increasing. We are Mach decimal 83. What airports are nearby? Let's hit M, bring up the map. We are here, U, DLH 361. We have ORUB there. Got Baghdad up ahead of us. So we'll see Baghdad and the River Tiber. So let's just slide across to the co-pilots side here. You can see the River Tiber weaving through Iraq, and then somewhere up here we will have Baghdad. Screenshot time, because that looks pretty cool. Look at that with the shadows. Oh, still got my wing lights on. Please tell me again how Microsoft Flight Simulator looks better. does. I don't think it does anymore. Landing lights off. Nose lights off. Wing lights on. Beacon needs to stay on. Strobe is in auto. And we can turn off the runway turn off lights. Still get a little bit of issue with the shadows sometimes, but for the most part it's sorted out. I'm really loving this this improved quality with the new graphics card. Yeah, so I think Baghdad Airport will be somewhere around here. What can I do? What can I play with? That's cool. You can see the nose is slightly to the left of where we're headed because of that crosswind. You can see the contrails getting blown from left to right as well, which is pretty cool. Very cool, in fact. So this is the view from the nearest airport, or the threshold of the nearest runway. That's us up there. Nope, that's Qatar, ahead of us, of course. If I go to the left, there's us. There we are. Lufthansa, with no wings, for some reason. That's curious, isn't it? Not sure why it's doing that. Ooh, that's a nice view. Running. Okay, I think I'm going to be a bit lazy today and have another break. And leave you with that view. Back shortly. It's amazing to think with the satellite imagery being injected in. Like, this field down here exists. You could go and sit in the middle of that field there if you wanted to. This muddy river here, which looks like it's got some copper or something, or maybe just clay. Again, that exists. You could potentially walk along that. It's just all out there to be discovered. You can definitely see that we're travelling not in a straight line, but we're going up and to the right. Should we jump inside and see what that crosswind is like now? Yeah, there we go. So we've now got a 70 knot crosswind. Our nose is there, and we're travelling in that direction there. So the track is firmly to the right. And you do notice this when you're flying the Cessna as well, and I guess the Aquila, which is a bit more recent for me. You do, if you've got like a focal point in the distance, you do find that it like drifts off to the left-hand side, even though you're maintaining a heading. That's how you learn how to do crosswind landings. You've got to keep the airport, or keep the runway in a fixed position in your windscreen ahead of you, even though the nose of the aircraft may be left or right. So the runway doesn't move. It takes a little bit of getting used to. You start by aiming for the runway, straight down the runway, and then as you start to drift to the right, you just tilt your nose to the left, and then maybe a bit more than you normally would, than you do to go straight, just to get you back on track. And then you just do some very fine tunings, and then you just find it's actually quite a natural process of lining up with a crosswind. You do a crosswind correction. So we've now got VO1 tuned into KIR. And then we've got this other one tuned into something. Don't know what that is. Can I do terrain scanning? There we go. I think with the new weather radar in 12.3, the tilt even works down here. So what can I do? Manual tilt. So I can even tilt it down. Maybe it's just for weather. I guess there's no weather really over here, is it? It's just sunny. But yeah, you can see some terrain to the right hand side. Maybe those mountains over there. As we get more towards Germany, maybe we'll be able to see some of the Alps on the ND. We'll have to wait and see. Just knock that off for now. Generally for takeoffs, you'll find one of the pilots, particularly in mountainous regions or where there is some kind of terrain around the airport, you'll find one of the pilots will have terrain switched on their side, and the other side will have weather turned on, because it uses the weather display system to show the terrain. What I'm going to do is I'm just going to reset this tilt back to 0 before I forget. So as you're climbing, you may tilt it up 5 degrees so you can see the weather above you. And then as you're descending, you may tilt it down to see the weather beneath you. I'm surprised it doesn't actually show the tilt on the ND, because it's quite important if you leave it and a non-zero tilt. So I'm just going to see if I can make this a bit better at filtering out some of these noises of me just moving my mouse around on the desk. And clicking. What else can I show you? I'll show you the overhead. I normally show the overhead. So, start at the top left, we have the emergency locator transmitter. It's currently armed. It's not really modelled. Cockpit door backup for locking is there. Cockpit door video isn't modelled. Air data inertial reference systems are all in nav, all looking good. Turbulence damping. Primary and spoiler and elevator controls are all there. Don't want to turn those off. Can I command an evacuation? Oh, I can, but I probably shouldn't. Let's see, emergency electrical power, just leave these all how they are. Ground proximity warning system, so you can turn it off for terrain. Not sure what those do. Oxygen supply. Oh yeah, you can call. Are these modelled? Here we go, ding. I can turn on the windscreen wipers. A lovely squeak to it. Not required when you're flying over Iraq. And then up here we've got the light which shows when the toilet's in use, so the pilots know when they can leave and go straight into the toilet. Portable equipment and wireless, I'm guessing that's when you've got your thing switched on. And then that light should be on, but it's not. You've got two engines, and then you've got the APU, and then for each engine you've got two fire suppression agents. So these are two bottles basically of fire extinguisher. You try one, and if that doesn't put the fire out, you can use the other. We can test the fire alarm for the APU. We can test the fire alarms for the engines. Hydraulics, so I mentioned we've got three green, blue and yellow hydraulic systems, and then we've got the RAT as well, which deploys and powers the green system, but these are just all switched on. And then the computer in the aircraft itself just manages the hydraulics. The fuel system, again, this is all just switched off, set to auto, and then the aircraft will move fuel around if it needs to. The center fuel tanks are actually empty, so if I turn these off, nothing actually happens. What I can do if I have an imbalance in fuel is, so let's say one of the engines is using more fuel than the other. If we go to fuel, so we've got slightly more fuel in the right hand side than the left, so that's got 8.7, that's got 8.8. What we can do is we can turn off the fuel pumps on the left hand side, and we can pump fuel from the right wing into the left engine. So let's do that. So we want to do turn on the fuel crossfeed. So that's now joined the right hand side and the left hand side up, and then we can start turning off the fuel tank, the fuel pumps on the left hand side. And now engines have still got thrust, and what we're seeing here is we've got fuel being pumped from the right side into the left engine. Also got a standby fuel pump. Where's that? Gosh, right. So the left-hand side wing is not fueling the engine at all. So the left wing is only providing fuel via gravity feed. And the right-hand side fuel tank is supplying both engines. You don't. This level of imbalance is not important. It's only if you start to get hundreds and hundreds and hundreds of kilograms difference between them. Usually that's caused if you've got a leak. In which case you wouldn't. If we had a leak in the left-hand wing, well, in that scenario, you've really got to balance the weight and the need for fuel in the engines. The aircraft, was it an Air Transat that ended up having to glide into the Azores when it ran out of fuel, due to a leak. That's what can happen. So if we had a leak in the left wing, that was leaking fuel. And then what we did was, set up a cross-feed. What did they do? I think they cross-fed from one tank to the other tank, which meant that the fuel was just leaking out of, the fuel was just being supplied to leak out of the other engine. So we're now back to balanced fuel. Put these back on. Turn off the cross-feed. We now have the same amount of fuel, more or less. I missed it by 20 kilos, but it's a lot closer. And then we've now got what we call tank to engine. Left wing tanks go to left engine, right wing tanks go to right engine. Fuel flow now is only 100 kilos per minute, which doesn't seem too bad to me. It's it's a person with a bag getting thrown into the engine every minute. Weight-wise, I mean, it's not how planes work. Just so you know. There's also different. So if you found that the, in fact, if I go to data, MCD menu, ATSU. I was wondering if there was some way. I thought it was somewhere in here where you could simulate a failure. Ooh, you can get a list of the traffic that's currently in view, so you can see them ahead. Guitar 2 whiskey. Flight ID on. Ooh, look at that! You can now display the transponder call sign next to the aircraft. That's cool. I like that. Let's go to MCD menu again. ATSU. What's in the ATC menu? Nope. What about failures here? Fault scenarios. What shall we do? Based on individual mean time before failure. Flight time factor. Let's enable random faults. Give it fairly high. Add a new fault. Ooh, okay. What can I do in here? Oh, right. What to do. So if we were to lose an entire hydraulic system, see. We bring up the flight control page. What could we lose? What could we lose? Okay, let's create a leak in the green system. Green hydraulic system leak. Now. And then turn off those faults. Apply. And then if we go down here, oh, I haven't turned the standby pump back on. Oh, I have. Low pressure fuel standby pump. Maybe that's the first sign. So if we go into the hydraulic system, you can see here the green level is starting to reduce, while the other two are in the normal range. And I wonder if that runs out of hydraulic fluid. I wonder if the electric pump, well, that's not going to do anything, is it? Because it's just going to pump nothing around. Interesting. Well, let's see. An ETOPS aircraft, we're in the middle of the Pacific, for example, and we're about to lose our green hydraulic system. We'll just turn that off for now. Fuel left standby pump low pressure. No portable devices. So we've got no warnings right now. We don't know that there's a hydraulic leak. Hydraulic fluid is getting dangerously low now in the green system. Wait for the plane to tell us. Calmly flying around. So Ninva is the crossover to the border between Iraq and Turkey. We've got, I think that's called CERT. I'm not just guessing because it's called SRT, but I think it's actually called CERT. Up ahead if we need to land somewhere. CERT, yes, double I. So what's the... looks like a long runway, doesn't it? We still have no warnings, which is interesting because we've lost about 80% of the hydraulic fluid. Is there anything modelled outside? Do we have any kind of leaks? Do some dirt. Can't see any new leaks. Nothing spraying out. I think that's quite common is for hydraulic leaks to occur within the engine. Might be completely making that up. Oh, I've got a master caution. We've got the hydraulics page up. So, what does it say? Hydraulic green reservoir low level. Turn off the pumps for the green electric pump. Sorry, green engine 1 pump off. Green electric pump off. So, green. Turn those off. Turn off the electric pump. And then this one. Is that what it said? Green system low pressure. Flight controls and wheels are affected. Okay. So I mean, this is going to make it interesting when we get into Frankfurt. We've got no hydraulic fluid there at all. Has the rat been deployed? I'm not even sure if that would be useful, because it would be driving nothing. It would be driving no fuel around, no hydraulic fluid around. As a passenger, no indication that anything's happened. And in reality, nothing has, because the plane has just... plane's got backups. If I do go into... so it says flight controls and wheel. If I go into flight controls, you can now start to see what's off. So we've actually started to lose some of our speed brakes. Ailerons are fine. Elevators are fine. It's really just the speed brakes. So if I jump outside and try to remember the button for speed brakes, which I don't think I have assigned. So if I go back inside, put the speed brakes out, quickly hop outside before it starts slowing down too much. Yep, you can see there's now gaps in the speed brakes that have been deployed, and those are the ones that were powered by the green system. The engines are just roaring now to compensate for me being a douche. Also mentioned that the wheels, there was an issue with the wheels. So if we go into the wheel screen, so we now have anti-skid isn't working. Nose wheel, steering, 1 and 2, no idea. So well, normal braking is broken. We've got alternate braking now. Yeah, I think that's it. So a lot of stuff just isn't working, but there's backups that are now just taking over. Pretty reassuring. So no need to divert. We've still got 2 perfectly working hydraulic systems, full of hydraulic fluid. Tempted just to leak the other 2 and just see what happens. Shall we? I think it's been so long since I've done a full flight, but let's disconnect, and then I need to do some rearranging. Didn't mean to do that. I was just moving my joystick. My creaky joystick. Apologies in advance. So if I just turn off the autopilot. Yep, that was fine. Kind of curious to know how easy is this now to fly with half the systems off. Alright, yeah. Squeak. It squeaks a lot when you're doing pitch, so apologies for that. But that is as responsive as I would expect it to be with everything working. So what else have we got to brake? Let's also brake let's leak the blue system. horn is just saying you're deviating from your assigned altitude, so we'll just pull back a little bit. Squeak. Pitch. And then we'll get back up to 38,000 feet, which is flight level 380. Come on, plane, you can do it. Just put the autopilot 1 back on. Get us back on a course. We should now also be having our blue system starting to drain out. We'll just keep that going for a bit. See what happens. Just step away for just a moment and then I'll be back. And we're back. Yeah, just had to sort something out. The green system is now empty. Blue system is draining. Surprised that you don't get a... when they're dropping so fast. Surprised you don't get an alert. So heading up north through Turkey right now. Still no warnings. And then I think right now the plan is to do an emergency divert to the nearest airport. Because we are going to lose flight controls, some of the flight controls after this, not just the speed brakes. This might be a bit challenging. And a bit squeaky on the flight controls, but we'll see. I'll try and save you from that if I can. I wonder how much of the autopilot can still work with some of these hydraulic systems being out. And then at this point, I guess you would have a divert airport in mind. But I'm just not that well organised, so... What's that one? Nope, that looks too small. Bingo. It's a longer runway? Ooh, that looks like a really long runway. This one called Mus Airbase. That could work. LTCK. Many years ago I did a round the world flight. Took 2 years to fly around the world in the Cessna. I'm sure that was one of the airports that I landed at. That's Cernak. Or Snack. Yeah. I think Mus is probably looking like it's going to be the best place to land. How's our hydraulic fluid doing? It's looking a bit grim, isn't it? Oh, look how you get the pixel effect on here. So that's pixelated, but this isn't. Well, it kind of is, but you can tell it's a screen. That's quite clever. So my squeaky joystick is a Thrustmaster HOTAS, so hands on throttle and stick joystick. So it's got a I don't know why it's so squeaky, and I did WD-40 it over the weekend, but it's still squeaky. It's got a throttle lever on it, which is quite nice. Got loads of buttons that are all programmable. Yeah, it's just nice. It's just that squeak. I don't know why it started to squeak. Probably from overuse. Now, I would expect to be seeing a reduction in the pressure in that hydraulic system now. I'm guessing the orange block there is maybe when it can't maintain that pressure. Getting pretty close. Still at 3000 psi. It must be like pushing the hydraulic fluid out of the plane through the leak 3,000 pounds per square inch, which is significant. Oh, we've got an orange line. Rats come online, so the rat's being deployed. That's going 6,000 RPM, that's very cool. We'll have a look at the rat in just a moment. Still got 3000 psi though. Does that wind down or does it just go straight to zero? Curious. This is telling me to turn off the blue engine pump and the blue electric pump, and it says rat out. You see the rat there now trying to power the green system, but the green is already depleted of hydraulic fluid. It's still saying 3000 psi. It's crazy. I'm just going to let it all drain out. Oh, there we go. You can see the hydraulic fluid pressure is going down. Now we've got lots of inoperative systems. The autopilot has disengaged. Auto throttle. Okay, so the rat is out. Where's the rat? Is it modelled? Normally pops out from underneath the aircraft, just here. I don't know, is it somewhere else on the A330, or is it just not shown? Oh, there it is. Ooh, it pops out from under the wing. That's interesting. So that's now providing some power. That's very cool. Didn't know it did that. So, we're now flying a crippled aircraft that's trying to climb. Do we still have normal law? No. So it looks like this is an alternate law. So, auto flight, autopilot off, land ASAP, rat manual on, speed brake do not use, maximum flight level 350, approach, slats flaps jammed, procedure apply. Okay, this is looking interesting now. So let's get down to 35,000 feet. So this is now flying basically like you would fly Boeing. So it's got no envelope protection. I should be able to just bank it right over if I wanted to, without the 67-degree envelope protection. Oh no, that is resisting. It's not letting me go beyond 67 degrees, so maybe it's not completely outside of normal law. I do need to try and figure out my way to... Is that the one there? Nope. Is that the one there? Yeah, so we're going to go to the right. Over speeding a bit here. It now feels... let's turn that off. It now feels completely unlike an Airbus. So... Oh, I'm going to use a lot of flight control to make it do what I want. Obviously half the flight controls aren't even working. Let's show you. So the rat is out, so if I'm trying to turn, I've only got some of those speed brakes now, and some of the ailerons. So this is a very, very crippled aircraft right now. Let's jump back inside. And we are going to stall unless we are very careful. What is the heading that we need to get to MUS? It's pretty much 90 degrees. Okay, so we'll head east. Squeak, squeak. Sorry about that. So I'm not sure what the best glide speed is for the A330-900. But the airport is 48-ish miles away. So I'm going to try and get us to that. Very, very sluggish. In roll. Very, very sluggish. We're going to just go direct to the airport, and then we'll figure out how we can lose some energy on the way if we need to. Now we've got a tailwind of 67 knots. So we might want to go downwind and turn back on ourselves. Just try and keep that speed. Maneuver with care. Do not use speed brake. Blue engine pump is off. So this is now saying this is all goosed. It's all off. Status. So for landing gear, gravity extension, max speed 200. Got the landing gear, gravity extension there. Squeak. So we'll try and maintain 280. I don't know what altitude that Musk is at. Musk Air Force Base. So it's at 4,000 feet as well, so it's quite a high altitude. Airport as well. Means we're going to lose a little bit of performance. I wonder if I can set up what's it called? Called LTCK. TCK. Oh no, hang on. So I think what you do is you go into the destination mode and then you say alternates for EDDF, LTCK. Run. No, you just put it straight into there. So LTCK. Nope. How does this work? Secondary flight plan. Copy active. Put destination change. You can see the trim wheels are still turning. Can I move those? Yes, I can. Okay. So we're now just basically flying it like it's a Cessna. Very, very large Cessna. The little rat out on the wing. Love that. Did not know that happened from there. We've got some terrain in between us. You can see it's just wobbling around a little bit. I think we're going to overshoot this airport. It must be below us now. There, that's it there. Looking for that brown rectangle. We're going to overshoot and then we're going to come back on ourselves and hopefully put her down there. Don't know how to delete secondary flight plan, in it to LTCK. Gonna do, let's see, LTCK. Slash LTCK. There we go. 306 on board. Right, I kind of need to get to the flight secondary flight display. Activate secondary. Oh, no. Right, we're just going to do this manually. So still at 25,000 feet. We are slowing down, so let's bring the nose down a bit. Do some trim just to keep it down. And then at this point we'll be making contact with them. We'll be getting their QNH, which is 1012. 1012. And helpfully, or not, the it says that we're now 33.5 miles to the right of our course, which is the RVSM or RNAV location precision indication. Do I have any? Oh, I do. I've got rudders. That's helpful. Squeak, squeak, squeak. Right, so I now need to sort of figure out when I'm going to make the turn. What I could do is just kind of enter into a right hand hold here. Almost like doing a spiral descent, but not quite. So spiral descent is where you have an engine failure and you spiral down over the airport, so you've got a better chance of landing on the airfield itself. Quite tense, quite tense. Can't use the speed brakes. Gonna have to do some kind of manual landing gear deployment, which I've never done before. Good thing is we're in the desert and there are some flat areas that we could probably just belly it in. Keep turning for now. So we're not going to be low enough on this turn, and that terrain below is actually looking pretty close. Let's pop the terrain scan on. There we go. So we're pretty much over the highest bit. We don't want to be doing that. We'll try and stay to the right a bit. even bloody clouds here. Sure, all the 330 pilots out there going, oh, but you should be doing this, or you should be using this descent indicator or something like that. Have I got a... it's called the FPA. Flight path vector. So the airport's there. Creak, creak. Oh, I need to lose 9,000 feet. Yes, it's not like we've lost an engine, just struggling with flight controls. That's pretty cool. That cloud just hovering over that bit of ground there. Squeak. So I'm just going to try and use this flat space over here next to the water to descend into. And then we'll have to start hoping for the best, surely. Trying to start thinking about what I want the long approach to look like. Those runways are 290. And the heading. Always nice to see a big mountain in front of you when you're flying. I want to see one of the creepiest stories of aviation. There was a crash in Antarctica. I think it was in the 80s. An aircraft full of sightseers on board, where I think it was in New Zealand plane, flying along, and crashed into Mount Erebus, because the sky was white and the mountain was white, and they didn't even see it, and they crashed without even realising they were about to crash. There's a lot of photos taken on board the plane before it hit the mountain. People didn't realise they were doomed at that point. And there's one picture which sticks in my mind, which is a picture of an aircraft window, like a passenger window, and on the window is hydraulic fluid. And what they think happened was somebody had their finger on the button to take a picture out their window, and at the instant of impact, when the plane was smashing into a mountain, the finger got jarred into taking a picture, and that's the exact instant of impact into Mount Erebus, which is pretty morbid, but fascinating in a way. Yeah, quite creepy. So we've got, how long have we got? 25 miles before the airport. Let's try and get a bit more energy into the system. Those mountains ahead look pretty high, don't they? So 20 miles to the airport. Let's give this a go. Squeak. Okay, we're losing a lot of speed very fast. I think it's possibly because of the rat, because I guess that's going to add quite a lot of drag. I know we can't do the gear extension above 200 knots. What that says. Slats flaps down, procedure apply. For landing gear, max speed 200 knots, landing gear extension down. So I guess we just... reset. How does that work? Definitely going to crash while I'm trying to figure this out. That's in the down position. No landing gear. Do I also need to do something up here? Approximately warning system. Fuel, evacuation, emergency power. Nope. Really high. Really high. Should have been paying more attention. Okay, so let's do some turns, steep turns. As we try and reduce Oh, look at that. That's beautiful. Still not seeing any landing gear. Wait for the squeaks. Needs must. Squeak. So then, what do we do here? Do we reset and then try again? Reset. Off. Down. Try and reduce a little bit of this. Altitude. Big mountains ahead. That landing gear is not coming down. Because of the speed we're at. Must be. So I'm just gonna see if I can do a very steep left bank turn to try and reduce. Ugh, that's really annoying me. It must be annoying you. Reduce some of our speed. I'm just gonna let the microphone off just for a sec. That was me trying some maneuvers to try and get the landing gear out. May have to do this without landing gear then. That's annoying.
2,500.
I'm going to do one more loop and then we're going to come in for a landing. Because there's the runway just there. I want to be as slow as possible and as low as possible. That's annoying. Right, I'm going to do a loop. So I think we're low enough now and slow enough that we should be able to do a belly landing. Because I've tried lowering the landing gear by the gravity mechanism thing and it's not working. So let's try and put this down without the microphone on because I will be squeaking a lot.
Too low, terrain. Too low, terrain.
500.
Too low, gear.
400.
Sink. Pull up.
300.
Sink rate. Too low, gear.
200.
Sink rate. Pull
100.
up. Sink rate. Sink rate.
50.
Sink rate.
40. 30. 20. Retard. 10.
So that's how you land a Lufthansa A330-900 after losing 2 hydraulic systems. Not exactly how I imagined today's flight would end. But here we are. Thanks for watching. Maybe we'll see you again.